So today I am going to get you to innovate about inertia. Inertia is how a body doesn't want to change its velocity. And velocity is speed in a particular direction. It means that if something is at rest, it doesn't want to move, it wants to stay at rest, or if something is moving, it wants to keep moving. I have an experiment, I have two actually, but the first one is that you're going to take a coat hanger and the pliers and you're going to unravel it and then shape it out into it. Here's what I prepared earlier. So I put it in the shape of an M and then I put two weights at the end of it. I've used tennis balls, you can use anything you want. And because I put two weights on it, because mass has something to do with inertia, the bigger the object, the less likely it is want to move or change it from moving if it's already going in a direction. So it's balanced it perfectly. There's a lot of tweaking and moving, and this is where the engineering finessing comes into this. Check this out. Look at that. So it wants to stay at rest. So at the moment it has inertia because it's staying still until I give it a force and it's like the babies things that are cribs that make them want to, that's because that's like inertia that's moving. I have it still and then I move, and only the friction on my head should move it a little bit. So if I move a little bit, so it doesn't move as much. The one you've probably seen yourself before is the one where you've got a glass, you have a tray of some kind and a tube and a ball or an egg on the top of it. And then when you hit this, because the ball wants to stay, has inertia and mass wants to stay in the same place. When you remove these, it should stay here until gravity takes effect and pulls it down. Okay, 3, 2, 1. Oh, 3, 2, 1. Yes! Great success! So this works, but how can we make it bigger? Because engineering is all about innovation, and I've got my jacket. Follow me and I'll show you a better version of this. So, come outside, got my jacket on, I've got my longer pole, and I thought I'd do a bigger version out in the big wide world. I have a giant cup, and we're going to call it an egg. It is actually an inflatable version of the sun. We're putting that there. This is quite difficult to balance the sun on top of. And also, when it falls over, it falls on the side. The experiment we did earlier on, there was a tray that blew off in the distance, so that's not ideal. So this isn't perfect. So I had to engineer a new solution. So what I thought I'd do was I would use these giant blocks of plastic bricks, and if I put them together, they might break when I hit a force across it. So if they break, then that means that it wouldn't matter if it hits the side or not. Stay. I get the sun. 1 second. Here's the sun. If I get this, I turn that upside down. Oh, wind. Whoa, whoa, whoa! The wind is. Oh, don't be windy now. Okay, now to put a force across it. Okay, here. 3, 2, 1. Did it go in? This way takes some practice. Engineering is all about practice and preparing and trying things out and figuring the answers, solutions to problems, ways that shouldn't hurt you. I need to practice. Keep trying yourself, and if there's a better way to do this, let me know. Oh.